So, what is the physical implication? So, if I were to draw the plot between vehicle speed and the engine speed. So, let us say this is engine speed, this is vehicle speed. So, let us say we take the two bounds of the speeds where we want to operate. Let us say this is omega t and let us say this is omega max. Okay. So, what is going to happen is the following. In the first gear, after it comes to a baseline slip and this omega t, the vehicle speed is going to increase linearly with speed, right, because it is in the first gear. Please note that in this expression we can immediately observe that this expression can be rewritten as V equals omega E multiplied by RW1 minus lambda NTI ND. So, let us say if I am on a particular gear ratio and I assume the slip ratio to be almost the same, right. So, we can see that there is a linear relationship between V and omega E. So or we can rewrite the other way, omega E is going to be equal to NTI ND divided by RW times 1 minus lambda V, because in this plot we are plotting omega E on the vertical axis and V on the horizontal axis. So, we can immediately observe that the ratio in this ratio of the straight line, the slope of the straight line in this graph is proportional to the gear ratio which is selected, and obviously as we have discussed, the first gear ratio is the highest. The value of the gear ratio decreases as we go from lowest to highest gear. Okay. Since the first gear ratio is the highest, we see that the slope is high here. Okay. Then what happens? We switch from first gear to second gear. So, we are going to get a profile something like this. Okay. Here the slope is going to be proportional to the second gear ratio. Then once we hit omega max, we once again upshift to the third gear. Then once again once we hit omega max, we upshift and then we go on, right. So, that is what is going to happen. I hope I did not draw it. 1 minute, let me just quickly redraw this. I do not want the slopes to be almost equal. Okay. So, the slopes essentially reduce as we go to lower to higher gears. Okay. So, that is the idea. Okay. So, this is what happens. So, we can see that the speed gap between two successive changes in the gear ratio keeps on increasing, right, with this choice, right. So, here it just it keeps on going, right. So, you can see that the delta V or the difference in speed between the change in the gears, right, as we keep on upshifting keeps on extending, right, with this mechanism of what to say, choosing the gear ratios and deciding upon the upshift sequence. Okay. So, we can see that this leads to what people typically refer to as a sawtooth profile, okay, between the engine speed and the vehicle speed. Okay. So, that is what happens with this particular case, right. So, we just plotted this from the equations that we have derived. Okay. So, and essentially as we keep on upshifting, the gap in the gap or the difference in the speeds keep on increasing. So, now what we will do is that we will ask one question, okay, and then we will try to answer that. So, the question that we are going to answer discuss is the following: what happens if, let us say, if n equals 5, that is we have a 5 speed gearbox, that is any n greater than 4. Okay, I am just taking a particular value n equals 5. The question the process remains the same, what we are going to discuss remains the same even if n is 6 and so on, right. So, we go for what to say, gears more than 5 typically if you want to overdrive, right. So, essentially the fifth gear will be in overdrive. What is overdrive arrangement in gears? The output shaft speed is greater than the input shaft speed. So, obviously the gear ratio is less than 1, right. So, that is what is called as an overdrive gear arrangement. So, what happens if in what to say in a 5 speed gearbox, still we need to find the intermediate gear ratios, right, do we not. So, let us say even in this case, by convention NT4 is taken as 1, okay, the fourth gear ratio is in direct drive, right. Let us say, like we can consider, see we can essentially say that by convention we are going to take the fourth gear as a direct drive and our intention is to have an overdrive. So, that is why we are going for the fifth gear, okay. So, now if the fourth gear is in direct drive, if we look at the equation for maximum speed, I will not be able to find ND. Why? Because the maximum speed will be obtained now when I am in the fifth gear. So, if I substitute small n equals 5, I still have two unknowns, right, because I do not know NT5, I do not know ND, right. This equation was used to calculate ND when we had a 4 speed gearbox and the fourth gear was a direct drive. So, it was very useful. Now, we have a challenge. So, the question is that, like, how do we address that? Okay, so, we are going to look at that briefly. So, still we consider the intermediate gear ratios to be in geometric progression, considering the set of gear ratios to be in geometric progression. We have NT2 by NT1 equals NT3 by NT2 equals NT4 by NT3, and that is equal to NT5 by NT4, and that is equal to K subscript G. Okay. So, in this equation, in this essentially sequence, we know only NT4, NT4 is 1, we do not know other gear ratios, neither do we know K subscript G. Now, the question is, how do we figure those things out? Okay. So, now in this scenario, the equation for maximum speed is, we are using the same equation, V max is going to be equal to omega max divided by, it was NTN, right, here n is 5. So, we get NT5 ND RW times 1 minus lambda. I have not done anything else, I have just taken the same equation, substituted n equals 5, right. So, from here we can immediately calculate the value of ND as V max, ND will be equal to omega max RW times 1 minus lambda divided by NT5 V max, right. So, let us keep this equation as it is. Now, the equation for gradability, still we want to climb the steepest grade when we are in the first gear. So, we use the same equation. So, the maximum torque is T max times NT1 times ND times eta T divided by Rw, which is the wheel radius, same equation, okay. Like, so I am not essentially changing anything. That is going to be W times sin theta S max plus Fr, right. So, this is the same equation, okay, for matching the powertrain output in the first gear to what is required by the vehicle to climb on a grade. So, from this equation also I can get an equation for ND. So, W sin theta S max plus Fr Rw T max NT1 eta T, right. Now, I am sure all of us can figure out where we are headed, right. We have two equations for ND, so we just use them, right. So, we just equate these two equations. I am just directly writing the final one. So, this should be equal to omega max Rw times 1 minus lambda NT phi V max, is it not, right. So, what is going to happen here? We can immediately see that Rw cancels off, then we immediately have NT phi by NT1 to be equal to omega max 1 minus lambda Te max times eta T divided by W times sin theta S max plus Fr V max, right. Now, what is NT phi by NT1? Kg power 4. So, that is going to be K subscript G to the power 4. So, this will give us K subscript G power 4, okay. So, find K subscript G, right. So, now the solution is obvious, right. Find K subscript G from the above equation. Then calculate, once we know K subscript G, what do? I go back to this geometric progression. Once I know K subscript G, then I can immediately calculate NT phi and NT3. Why? Because NT4 is 1. Once I calculate NT3, I can calculate NT2. Once I calculate NT2, I can calculate NT1. So, then we can calculate. So, I am writing in this sequence NT5, NT3, NT2, NT1. Okay. The reason I am writing in this sequence is clear to all of us, right, because we have NT4 and Kg, we go in the sequence. Then we can always calculate ND, right, because we already have an equation for ND, right. So, we can calculate the value of the final drive ratio. So, this is a very simple process to adopt when we have more than 4 gear ratios with the higher gears being what to say required to be overdrive. Okay. So, what we have done is essentially match the transmission or the powertrain requirements to essentially overcome the loads on the vehicle at a particular operating condition, right. So, this process, as I mentioned, is broadly known as transmission matching, okay, because we are matching what the powertrain or transmission can provide to what is required by the vehicle, right. So, that is the concept. So, before I just quickly close this discussion on transmission, I just want to introduce functions of two more components, then we will close the discussion on transmissions. Okay. So, the first component is what is called as an interlock. Sorry, let me first maybe introduce retainer. Okay, the first sorry about that. So, the first component which I will introduce is what is called as a retainer. So, this goes back to our discussion on the transmission components. If you recall the selector rod in the multi-speed gearbox and so on, right. So, that is what we are essentially discussing. So, what is a retainer? So, we have already looked at this what to say selector rod and how the gears are selected, right. So, let us say this is a particular selector rod. Now, what happens is that this is when the selector rod is in neutral, and the selector rod, as we discussed, one selector rod can be used to push one synchronizer either side. So, these are let us say two gears. Okay. So, let us say this is gear 1, this is let us say gear 2, okay, without loss of generality. What happens is that like this retainer is essentially a spring loaded ball. Okay. So, this is what is called as a retainer, okay, this assembly. So, you have these grooves where these balls are located, and that is held in place by this coil spring. So, when we push the selector rod, let us say like we are pushing the selector rod in this manner, then what happens, this due to the force applied on the selector rod, this ball is pushed into the groove against the spring, and the spacing between the grooves is such that it is calibrated to the displacement of the selector rod to engage a particular gear. So, let us say for example, when the first gear is engaged, the ball will fall into this corresponding groove, that is this one, right. So, what it will do is that it will give two things. First, it will give a like positive feel that a gear has been engaged, and it will also ensure that the selector rod is held in its place or retained in its place, okay, even in the presence of some small vibrations, so that the gear does not get disengaged even by accident. It is not going to get, this is just a fail safe, right. So, that is why it is called as a retainer, right. I hope the function of a retainer is clear. Okay. So, another component which is once again a fail safe mechanism that is used is what is called as an interlock. So, what is this interlock? So, an interlock essentially ensures that two what to say selector rods do not move by even accident. Okay. So, as I told, it is once again a fail safe mechanism. So, what happens is that like an interlock is this mechanism. You can see that typically let us say we have 3 selector rods. So, we have a groove in the central selector rod, let us say we call this as selector rod 1, 2 and 3, right. So, in selector rod what to say 2, there is a what to say a hole, and then a pin is fixed in that, and then we have 2 balls floating in these grooves. Okay. So, this is the neutral position. Okay. So, when none of the gears are engaged, right. Let us say now if we push selector rod 1 up, what is going to happen is that this ball is going to be pushed out of the groove, and it is going to push the pin, and it is going to push this ball against the 3rd selector rod, right. So, the 2nd and the 3rd selector rods are held in their position by this mechanism. Okay. That is why it is called as an interlock. It locks the other 2 selector rods. Now, let us say when the central selector rod is pushed, let us say selector rod 2 is pushed, what happens is that these two balls are taken out and then they essentially get pressed against the two outermost selector rods 1 and 3 here, right. So that other two selector rods do not move by accident, okay. So that is the function of an interlock. So retainers and interlocks are fail safe mechanisms, okay. So I will stop my discussion on transmission with this. So let us continue in the next class. Thank you.